All right, this is your friendly neighborhood professor talking about extraneous and confounding variables today. So before we get into extraneous and confounding variables, I want to remind you what we're talking about with an experimental study. So an experiment controls extraneous variables and it manipulates independent variables. So that's what we're talking about here. And this idea of internal validity is that we are trying to separate our independent variable and be able to say, we think our independent variable actually caused or had an effect on our dependent variable. So extraneous variables can get in the way of that. They can obscure it. They can make it confused and hard to tell what had an effect on what. So we're looking at how do we increase our internal validity we control for our extraneous variables. So extraneous variables, just as a quick review from lecture, they're anything in the context of experiment that are not what you are trying to study. So you came up with a research question and a hypothesis for your studies that you're doing this semester. And we're looking at this idea of what are you studying? You chose specific variables. Those are our variables of interest. And in an experiment, we have an independent variable that we manipulated and then a dependent variable. Anything else, anything that you didn't specifically identify, those are extraneous variables. And the goal in experiment is to hold them constant, that we control for extraneous variables. And I'm going to give you some examples of this. But if you don't control them, they can become confounding variables. So again, confounding is confuse. They're variables that could be an alternate explanation for the change in the dependent variable. So let's look at an example. So first, let's make sure we're clear on this independent variable versus dependent variable. So independent variable is our expected cause, and the dependent variable is our expected effect. We want to know, did our independent variable have an effect on our dependent variable? So the idea here is we're thinking about this independent variable, we're looking at it and we're saying, okay, we're going to manipulate this variable, and that's going to have some effect on the dependent variable. We're not just measuring this independent variable, we're actually going to change it. And we think it's going to have some effect on this dependent variable. So think about it physically pushing the dependent variable. When you change something in the independent variable, you think it's going to push our dependent variable in one direction or another. So extraneous variables are potential other explanations for a change in the dependent variable. And these are potential third variables. We talked about this idea of not knowing, with correlational research, not knowing maybe there's a third variable that could actually be the reason there's a relationship between our independent and our dependent variable. So for this idea of confounding, the difference here is that the confounding variable is related to the independent variable and the dependent variable, whereas an extraneous variable, it doesn't have a relationship with our independent variable. So think about this confounding variable as something that changes depending on the level of the independent variable. And now I'm going to get into our example and we'll talk about this a little bit more. Hindsight bias is a phenomenon in psychology, and I'll be using this in the hindsight, or in the phenomena versus theory video as well. So we've talked about this really briefly, but hindsight bias is this idea that when we know the outcome of something, so we know what happened, we tend to overestimate our ability to have predicted that outcome. So for example, when I gave you back your exams for exam 1, you looked at it and some of you were like, I totally knew the answer to that question because of this connection and this connection. And I looked at this and I knew that that was what it was. But did you though? So we overestimate that ability to have known the outcome, because now we know it, we can look back and say, oh, there's this connection to it. This is what happened. So we might look at election outcomes, for example, and somebody won, and you think, oh, I totally knew that they were going to win. because of this connection, this connection, and this connection. It's like, well, you didn't know about those connections until you knew that they won, right? So hindsight bias, let's imagine that I give you a study guide and I decide to split my class into two groups. And I'm going to do the study guide with the answers and the study guide without the answers. So what I want to know is, does this idea of different method of studying, so with the answers or without the answers, does it have an effect on exam score? So what I'm looking at again is there an effect of answers or no answers on exam score? So what we have here is we have our independent variable, and you can pause this, take a minute to think about it, figure out what you think is the independent variable here. But this here is our independent variable because we think it's going to push our exam scores in one way or the other. That if they have answers or without answers, that there's going to be a difference there. So we might think our with answers people are going to have a lower exam score versus the people who did not get answers. So this would be our basic study. So these are our variables of interest. These are the two variables that we're trying to isolate and try to determine how one affects the other. So we have our dependent variable of exam score over here. We want to control everything else. So what I mean by that is when you're setting up your study, when you're setting up your study, you are trying to answer this idea of, okay, we have two conditions. So we have condition A, we have condition B. We want to know, does having answers for a study guide or not having answers, does that somehow affect our dependent variable of exam score? So we have our condition A, and we're going to say that's with our answers. And then our condition B is without answers. Now, you can think of the control condition as your kind of status quo or what's normal. So our control condition is that I give you a study guide without answers, right? So this could be our control condition, and this could be our experimental condition. But they're just levels of our independent variable, right? So these are our levels of our independent variable. And what we want to know is this going to have an effect on exam score? So if we were to test this, will exam score go up for one group and down for another? So let's make a hypothesis. Our hypothesis is that students who have an exam guide with the answers, they're going to have a lower exam score than people who have it without answers. So this is going to be higher. So again, you can think of it as like physically pushing our independent variable. It's physically pushing our exam score. And this hindsight bias, the way that this comes together is that for hindsight bias, we think that having the answers ahead of time or knowing the answers is going to reduce our ability to recognize what we actually know. So if I gave you a study guide without example or without answers, you have to go and look for it. You have to really identify whether or not you know the answer to that. But if I gave you a study guide with answers, you might look at it, read it, and say, oh yeah, that totally makes sense. I know the answer to that. And that's dangerous because we overestimate what we think we know if we already have the answers. So this is the long explanation for why I do not give you answers on your exam study guide. You need to go find them for yourself. You need to identify what you do and don't know in your own way, right? So now let's talk about extraneous variables. I might have some, I'm going to use a different color here. So my extraneous variables, I might have gender of my participants, right? So we have our two conditions. Gender would be an extraneous variable. Let's do another extraneous variable is, we'll just say the baseline grade in the class. So I'll use grade, but basically your kind of baseline comfort with the materials, your success so far in the class, things like that. But we'll say grades. There's different grades. We can also say there's different, let's say different motivation to study, different motivation. So these are individual level. These are individual level characteristics. So our goal is to control for these extraneous variables. With individual level characteristics, we can control them through random assignment. So we can randomly assign people to be in one condition or the other. And so for this example, we would expect that if we randomly assign people, we would end up having different baseline comfort with the materials across both conditions. We would have different levels of motivation across those conditions. We would have different genders across both conditions. But what if I decided to do a motivation test? And I said, you know what? I want to know what the motivation level is of participants. And I'm going to put my low motivation people, so low motivation, all in my condition A, and my high motivation people all in condition B. So now I have an alternate explanation if this ends up being the result here. So let's say that we end up getting lower exam scores for condition A. Well, the problem is you now have the independent variable, but you also have this motivation variable. So motivation could be your alternate explanation. It's a third variable. We don't know if having an exams guide with or without answers had an effect on exam score, or was it motivation because we didn't control that? That is a confounding variable. So it could have been extraneous if we did random assignment, but because we did not do that, because I said I'm going to purposefully put my low motivation people in condition A and my high motivation in condition B, that would be considered an individual level characteristic that we didn't control for, that is actually systematically different because it goes with the levels of the independent variable. And so now we don't know which caused the change in the exam score. So that is an example of an independent, or of a confounding variable at this individual characteristic level. So let me clear this, and I'm going to go ahead and do another example. So now we've talked about individual level characteristics being confounding. So let's go back to our condition A, which was the answers. So we're going to say with, and we have B without, and we think, this is our independent variable, we think that this is going to have an effect on exam scores, right? So same situation. Now, we talked about individual level confounding variables, right? Now, let's just go ahead and say we did random assignment. We did random assignment to conditions, and so we randomly assigned some people to A and some people to B. So we don't have any individual characteristics that are confounding because we used random assignment. But there are other types of confounding variables. So let's say that we're trying to test this with answers or without answers, but it's a different exam guide. So exam guide 1 has less information than exam guide 2. So now this condition A is going to get the less information. So it has fewer terms on it, whatever it might be, less information. B has more information. This is not an individual level extraneous variable, but it is a condition. It's a part of the condition, right? So this is looking at, this basically gives us another alternate explanation for why they might have a higher or lower grade. So again, we're saying this, we think this with group is going to have a lower exam grade and the without group is going to have a higher exam grade. So what you would do, the way that you control this so that the exam guide itself, the type, the less info versus more info, the way that you would control it so that it's not confounding is you would have the exact same exam guide. So you would have it be the same. So the with exam guide and the without exam guide, they're the same one. The only thing that's different would be the with or without answers. That's the only thing that would be different. So that's why when you created your studies, I had you use the same wording in your two different conditions. I asked you for videos to have them be about the same length so that length wasn't a potential confounding variable. So you're trying to make sure you're trying to isolate the effect of your independent variable so that when you're done with your study, you can say, oh, we controlled our individual level variables. We made sure that our conditions were the same except for the independent variable. We're pretty confident that the difference in exam score actually came from that independent variable. So to finish up here, I just want to demonstrate with an example on a graph. So the goal of the study, again, is to compare the effect of our independent variable levels on our dependent variable. So here we have our exam scores. This is our y-axis up here. And let me get a, here we go. So this is our y-axis and this is our x-axis. So our y is our dependent variable. That's our exam score. So you always put your dependent variable on your y-axis. And you can see here that our condition B without answers is higher, right? So that's the higher exam score. So this is an 82 and this is a 75. If we properly controlled our extraneous variables and don't have any confounding variables, we can say that we're pretty confident that not having answers had an effect on exam score. So that's our goal with controlling confounding variables, is that we can say we're pretty confident that our independent variable had an effect on our dependent variable. So I hope this helps. Make sure to reach out to me with any questions that you might have. But that is the end of our video. If I can get this to close.